Let's do another cliff problem here. So we got a ball leaving the edge of a cliff. It's going 12.5 meters per second, purely horizontal velocity, right? Lands 25 meters from the base of the cliff, right? So now we know this velocity. Don't know the height of the cliff, though. We're going to have to figure that out, right? Okay. So let's draw a little picture here. Here's our cliff, right? We're landing 25 meters away, right? So here's this thing. It's got this purely horizontal velocity. This is 25 meters, right? We know that it's going 12.5 meters per second right there. Okay, so what do we know? So the 12.5, that's the horizontal velocity. That must go here, right? You can fill those in. They're always the same. These guys are always equal because this is 0, right? This is always negative 9.8. The initial velocity, if it's purely horizontal, this guy is always 0. There isn't any vertical velocity, in other words, right? And then we know this 25 from the base of the cliff, that must be our horizontal x, right? And now we've got this sort of unusual thing where we can actually solve this side, right? All we ever do horizontally is use this guy, right? Where v is x over t, right? So now we want t. If we cover up t, it's x over v. So 25 divided by 12.5 is 2. I didn't use a calculator for that, right? That's just 25 over 12.5, right? Okay, so I'm just using the triangle there. We've got that. The 2 goes across. And now we're set. Now we can figure out stuff here, right? Our final velocity. To find the final velocity, I'm going to use VF as VI plus AT. Because I want to use no x, right? Okay, so VF is 0 plus negative 9.8 times t times 2, right? So that's negative 19.6 meters per second. And then I want to figure out the height of the cliff, right? Let's see. So the displacement is going to be x is VIT plus 1/2 AT squared. Notice that the initial velocity is 0, so that goes away, right? And we just end up with 1/2 AT squared. So 1/2 negative 9.8 times 2 squared, right? Well, 2 squared is 4. Half of 4 is 2. 2 times 9.8 is just negative 19.6. So we've got this weird thing where the displacement's the same as the velocity. What does it mean, really? What does that mean? Nothing, really. It's just a kind of a coincidence. Okay, so let's see. What questions have we answered? What time does it take to hit the ground? 2 seconds. Yeah, we got that. What is the final vertical velocity, right? Just before it hits the ground. So don't be a smart aleck and go, well, it's 0 because it hit the ground. This is negative, right? So it's moving down. And we actually got that negative fair and square from 2 times negative 9.8, okay? If you ever get a number that's not negative, just slap a minus sign on it. It's always going to be going down when it hits the ground. And then the displacement, what is the height of the cliff, right? How high is the cliff? That's A, right? Well, we go down 19.6 meters to get from the top to the bottom, so the cliff is 19.6 meters tall. Now, I'm not going to ding you if you say the cliff is negative 19.6 meters tall. It's kind of a funny way to say the height of a cliff, though. Okay, so we're going to use these numbers, this 12.5. That's all we really need for the next part. Okay, the next part says what is the velocity as a vector. So let's look at that. So this, if you recall, was 12.5. This was negative 19.6, right? And all this stuff was, we don't care, you know, it was something, right? We'd fill that in, right? But this is what you take out and you make that into your velocity vector. This is your x direction, this is your y direction. So if we draw this thing, it looks like this. It's over, right, about 12.5. Notice I'm going to make my 19.6 look longer. And then this is the vector itself. Ooh, that was a good straight line. You got to admit that. You got to give me that. All right, so let's see. Let's find this angle. Let's find the hypotenuse, because that's what we want to find, right? Okay. So that angle there is going to be the inverse tan. Theta is, so this is 12.5. This is 19.6. So that angle is tan minus 1 of 19.6 over 12.5. Let's use our calculator for that. Inverse tan of 19.6 divided by 12.5. So this, by the way, this number, we would disbelieve a number smaller than 45 degrees, correct? 57.5 roughly. Okay, so with three numbers, if we round it to three numbers, 57.5 degrees. Okay. And then our magnitude, we're just finding the hypotenuse. This is the Pythagorean theorem here, right? So the magnitude is also known as the speed, if it's the velocity vector, right? These are synonymous. The magnitude of velocity is also the speed. So let's see. That would be the square root of 12.5 squared plus 19.6 squared. Now, you don't put minus signs in there. I know that's negative 19.6. Don't be putting them into your little square root things, unless you put them in parentheses, because your TI calculator will betray you. Okay, so it's 12.5 squared plus 19.6 squared. When I do that, I get 23.2 meters per second. That's the speed. That's the magnitude of the velocity, right? So this guy is 23.2 meters per second. Yep, so we got our answer like that.